Phase Change Engineering Internship Day 10, Applying Engineering Skills. If you're watching the video instructions, they cover the entire lesson, so you will need to pause the video when necessary. Activity 1, Connecting to Futura Workspace. You'll read today's message, "Thanks, interns." However, instead of taking daily message notes, you'll take the Internship Exit Survey. Students open Futura Workspace and read the daily message from the project director. Remember that the new message, titled Day 10, "Thanks, Interns," should be at the top of the inbox. Begin working on the Internship Exit Survey form. You will have time to finish and review your answers to the survey in the next activity. Teacher, reflecting on the internship. The Internship Exit Survey is your final deliverable for Futura Engineering. Submit your survey once you've completed it. Futura provided the survey to find out what you think about engineering and your experience as engineering interns. Sometimes it is helpful to talk through difficult concepts to help you understand the concepts more clearly than if you were just to think about them on your own. You'll discuss the questions on the survey with a colleague. Take turns answering each question on the survey. Imagine you're talking to a new intern. Did you and your partner answer any of the questions differently? Do you have any questions? Thank you for your hard work on this internship. Let's discuss your final reflections on your internship experience and how you liked working as a chemical engineering intern. What advice would you give to future interns? What did you like or not like about the internship? What were you excited about learning in the field of chemical engineering? Now the internship is over and we're returning to our roles as teacher and students. Teacher, applying engineering skills. For your portable baby incubator project, the problem and the 3 criteria were defined by Futura and the Global Health Organization. Today you will expand your thinking about engineering, define a new problem, and come up with your own criteria to define its solution. This will give you a chance to apply some of what you learned in your internship. We can choose option A or option B and follow the steps of our choice. Option A, revising the general portable incubator design and baby warmer design tool. Option B, defining another problem related to phase change materials, PCMs. For option A, you will be rethinking your portable incubator designs and the baby warmer design tool. On your own, you can brainstorm ways you'd like to change the incubator model, as well as additional constraints to consider and new criteria you might like to test. Here are some questions to keep in mind as you reflect on the current design of the incubator. How can you make the incubator design better? How easy is it to learn and use it to fix it if it breaks? What features would you change in or add to the baby warmer design tool? What are some other constraints and criteria you could define for this problem? Option A will ignore the next 2 slides. Option B, your new task is to think of other problems a chemical engineer might try to solve through knowledge of phase changes. Then use the next 2 slides to help brainstorm new phase change problems. This is part of option B. You'll think of a new phase change problem, such as keeping something cool, keeping something besides a baby warm, or preventing something from becoming dangerously hot. This is also part of option B. Take a moment to think of some problems that are related to phase changes, keeping things warm or cool, preventing things from getting too hot. This is part of option A. You'll work in groups to think of problems to solve. Later, you'll have a chance to sketch some possible solutions. Share and discuss your ideas for new problems. Then choose one problem as a group and describe it on your sheets. Next, you'll come up with constraints and criteria. These are very important to defining an engineering problem as well as evaluating potential designs. Let's clarify the difference between constraints, or limitations or restrictions on the solution, and criteria, standards by which the solution will be judged. Let's review some possible examples of constraints. These are just examples, and your group can come up with other ideas you think would be important. Examples include must be built in a certain amount of time, must use specific materials, scientific concepts that must be considered, needs of the target population, safety considerations that must be included, potential negative environmental effects that should be avoided. The first category for a constraint listed here is must be built in a certain amount of time. You can use this to define a more specific constraint, such as your design must take 10 days or less to build. Criteria, standards by which the solution will be judged. Here are some example criteria. Remember, these are just examples. You should brainstorm your own criteria specific to your new problem. Examples, lowest cost to make, use or repair, biggest or smallest size, ease to make, ease of use, least amount of energy required to make or use, aesthetic value, most efficient performance. The first criterion listed here is lowest cost to make, use or repair. Your design might be judged by how much they cost to make. Designs that cost less might be more likely to be chosen than ones that are more expensive. As you discuss constraints and criteria, you use the questions on the sheet to help guide your thinking. For example, you might consider science ideas, people's needs and desires, economic limitations, limits to natural resources, or something such as climate about a particular place where your design would be used. Brainstorm several possible constraints and criteria for your new problem. Then record a few on your sheets. Next, you'll think like engineers to sketch a solution to your problem. Feel free to explore all ideas, whether or not they might be possible. This should be a brief sketch, as there is limited time to design a solution right now. Brainstorm and sketch a possible design that uses your defined criteria to address the problem you selected. What problem did you define? What constraints did you come up with? And what criteria did you select? Option A, students. What did you change in your incubator design to make it better? What ideas did you have for how to improve the baby warmer design tool? How were your solutions similar or different? Did different criteria lead to different solutions to the same problem? End of lesson.